This paper was presented at the JCT Traffic Signal Symposium 2024, thanks to our media partner Highways News, and sponsored by AGD Systems, Four-Way Consulting, Traffic Group Signals, Smart Micro UK, TRL Software, PTV Group, Census Networks, and Starling Technologies.
Morning everyone, thank you for being on time this morning after the night before. So we've talked over the last, or we've heard a lot over the last few days about data and detection and new types of detection. And I think if you walk around the symposium, you'll see a lot of new types of detection out there. And we talked a lot about how we can use it. So what I was going to talk today about is what we're doing in TOPAS to try and put some standard behind that and some guidance to try and bring some benefits to the user community. So that's what we'll step through. And the aim really is to provide awareness of where we've got to in doing this. It's not finished. We do have a roadmap to finish it. The reason for talking about it now is it's getting to the point where we'll be looking at trialling things on street. And it's good to start to get input from a lot of the user community. We've had a lot of input already, and I'll talk about that as we go through. But it'd be really good to get some further views and input as we go through. So we'll step through where we've got to and what it's about. So firstly, what is enhanced detection? What do we mean? So if we think about traditionally what we're used to with whether it's an MVD for vehicle detection or curbside detector, on-crossing detector, we're really detecting, we've got a detector to detect one object in one area and send one message to a traffic signal controller. And in there, I've said traffic controller. What we really mean, I guess here is the grey box. When I talk to my firmware engineers about what a traffic controller is, they mean some software running on a primary and secondary processor. Here, I think we're talking about a controller as everything in the box. And that message is a fairly dumb message. It's just a one-off, an on-off. And it's just performing one task. So in the example there, I've just said detector A is connected to an input in the controller, and that's providing a demand or an extension for phase A. So that's what we're used to with traditional detection. What we're now seeing is the introduction of multi-zone, multi-object detection, and the ability of the detector to send quite a complex message back to the controller, and whether or not that's connected to the controller or an outstation or another piece of hardware. And it can send messages for various different things. So whether it's detecting multiple vehicles, multiple types of classification of vehicles as well. So that's what we really mean. That's the distinction between enhanced detection and normal detection. And what are people using it for? So I've got some quite simple use case examples, but I think it sets out quite well why you would want to use enhanced detection. So on the left there, we've got two zones specifically looking at detecting larger vehicles, whether that's a bus or it's a HGV. It could be a HGV on an uphill approach to a set of signals. And that's information that will be useful to have in the traffic signal controller. And next to that, we're looking at another use of classifying vehicles. At the moment, you might have an overhead detector that's just detecting something at the stop line. It might have seen a bus, a car, a cyclist. But what you really need to know is it a car or is it a cyclist? And if you're looking at cyclists in particular, you might want to know how many cyclists are there. So in this example, we are looking to try and make the decision on whether or not we implement an early start for the cyclists, and we might not want to always do that. So I've driven around various places in the UK, and sometimes the early cyclist approach always comes up, even if it's just detected me at the stop line in a car. So having the ability to determine, is it a cyclist, or in fact how many cyclists are there, would be very beneficial to the operation of the site. So just there, a very simple table of logic that you might have inside a controller or an outstation. So using one detector with two zones, you can then determine if you have a car, if you have a cyclist, and in fact how many cyclists you do have, and then you can change the reaction to that based on the volume of cyclists. So currently, as I said, there are a large range of different types of detection products available, and they all have potentially different methods for cabling, different requirements for the cabling, different cabinet hardware requirements. And what that means from a local authority perspective is it's difficult to change between types of detector or manufacturer of detector. We don't have any interoperability between the manufacturers, and that's because of a lack of standard. And also trying to understand what the detector can do and how well it performs as well. And I'll come back onto that as a separate topic later on. So the proposal is to introduce a new specification, which we called the Enhanced Detection Interface specification, and it has two parts. So we will have the traditional written specification that you'd expect from TOPAS, but we'll also have an online repository containing downloadable information for manufacturers, for example, and I'll get onto that again in a minute. The aim of that is to create some consistency in the market and create interoperability for local authorities. So just looking at the standards, where will it fit in? So at the moment, products are registered, for example, if you've got an on-crossing detector, you register against 2506, and local authorities can look up against 2506 and see what products are registered. That will refer to 2523, which is the interface specification. 2545 will sit alongside that specification. It doesn't replace it, and in fact, it doesn't replace any of the standards that we've currently got for above ground detection, because there is still very much a need in the industry for basic, simple, low-cost install and point above ground detectors. So this isn't to replace that, it is very much to sit alongside it. However, coming back to the point I made earlier on functionality and how do you know how well a detector performs, there isn't a standard for that for enhanced detection. So there will be a new standard added to that group of standards, which doesn't have a number, 25XX, and there is a separate working group looking at developing that. It's being led by Mark Cladell, sat over there, and I know Mark is keen to speak to people about that as well, so the working group has just started for that. And Mark touched on the point in the movie user group asking for information and metrics about the current performance of above ground detection. So if you have any thoughts on that or information on that, Mark will be keen to speak to you about that. Just a point to note there that the manufacturers will continue to submit one application as you currently do. So this doesn't mean that you would have to register, for example, an enhanced detection that could also work as a curbside against the new specification and the curbside specification. Within the new multi-zone detection specification, there will be a set of appendices and you can register a product against the multi-zone detection standard against as many or as few of those appendices as you need to. So just in terms of the message format itself, it's based on an ISO standard, 10711, which has been around for some time but not widely used, well not used at all in fact across Europe. It's got a really catchy title that I won't read out. And essentially what that does is set out a standard for sending enhanced detection messages to controllers in a standard way. So on the left we can see that for every detector you have an ID and a location, and again you can have as many detectors on a site as you want. Each detector then has multiple zones, and each zone, as you can see in the middle box, has a header of information. So every zone would have that standard information as specified in the ISO standard. What the ISO standard does allow is extensible features to be added as well. And that's what we define in the TOPAS 2545 standard. There's a set of agreed extensions as we agree as an industry on what information we want to send between enhanced detectors and controllers, and that would then become the TOPAS standard. So we've got further information on that. The ISO standard we can't distribute. Obviously, if you want to see that, you need to buy it under the terms of ISO. But what we have done is distribute the compiled ASN.1. So ASN.1 is a language which basically provides a structure for sending sets of information. We've compiled that into a number of programming languages, C, Golang, Python, and they're available for download from the TOPAS GitHub. The physical connection, so the written part of the standard will look at the physical connection, and that will be centred on the use of industrial Ethernet. So there are different allowances within that, so wired end-to-end, wired to wireless, then wireless back to wired, for example. So that the written specification will go over that. It does allow for long distances, so we have chosen a technology that does suit the use case that we're looking for in traffic signal sites. And we're hoping to circulate that part of the specification quite soon. I'll come on to that in the timeline. So how have we got to this point at the moment? So we've had a working group looking at this for some time. We have stopped and started, and we have picked it up over time, but it is gaining some traction towards the end now, hence the presentation. So it stemmed from interest from the ITS working group within ARTSM, and ARTSM have very much supported this through the group with volunteers from around ARTSM and outside of ARTSM as well to pull it together. So that is a collection, I think, of everyone that's been involved in it so far. So you'll see, obviously, all the people you would expect, hopefully, to see on there. If anyone does want to form part of the working group or have any more information about what's happening within the working group, there's some contact information at the end of the presentation to do that. In terms of the project timeline, we do have a working group meeting at the end of this month where we will finalise the timeline, but we are essentially now looking at site trials. If anyone is interested in looking at site trials, contact me as well. And as I've got a red light and I'm being waved at by Jenny, I'll just move on to the summary slide. So essentially we're aiming to provide standardisation to enhanced detection, which will offer a lot of benefits around the industry. And I will just make one final plug, completely separate topic, but TOPAS related. We are looking to review TOPAS 2500B, which is the traffic signal controller specification. And again, if anyone has any requirements for that or would like to be involved in that, if you can contact us at TOPAS on that email address, please. And that's it from me. Thank you very much.
Thank you very much, Martin. That set us up nicely for today. A nice, solid standards presentation, just what we need to get in the serious mood. I'll take one question, and I've got Mark Playdell already, so please go.
I did say you weren't allowed to ask questions, Mark.
Thank you, Jenny. I don't need to introduce myself. Martin, rest assured, it's not a question, it's an observation for the benefit of the audience that this is a one-directional flow of information detector to controller.
Yeah.
Any information going the other direction will still be proprietary, et cetera, et cetera. We chose to bite off as much as we felt we could digest and usefully do, rather than bite off too much and fail to do any of it. So yeah, that's really for the benefit of the room.
Yeah, thanks, Mark. I did mean to make that point, so thank you. Yeah.
Thank you very much.
Thank you.
You may now sit down.